I think the next thing I have to do is actually introduce our opening speaker, which is Werner Heijstek. And he's going to talk about something I've had to work with and had to explain to a lot of people, and that's technical debt. And the fact that you can build up 2.5 years of technical debt in about 3 months, that's a trivial one. The fact that nobody understands that it's a debt, and if you need to repay it, it's with interest. That's something most banks understand, but other organizations still don't. But I hope Werner is going to talk and teach me even more about how to fix it. So, good luck.
Thank you very much. Let's first get this in place. Always a great start. So there's some speakers who are not here yet. So is the speaker after me here? Okay, so I have to actually stick to my timeline. So good morning. Thank you for having me. I would like to start off my contribution today with a small confession. When I started developing software, I think maybe it's better to refer to it as programming for money, more than 20 years ago. I made a lot of horrible software. Really, really awful stuff. At the time I didn't know it. I was actually very happy with what I made, and most people who paid for it also seemed very happy. It worked, mostly. So everything was fine and dandy. Until a couple of years into doing this work, I had to extend somebody else's application. I'd never done that before, so I opened up this application, I looked at the source code, and I thought, what? This is impossible, I don't understand this is horrible. And then I realized I have done this to other people systematically. I've left them with an insane mess of stuff that looks great on the outside, but is horrible to do anything with if you actually have to extend it on a source code level. Of course, nowadays we refer to this as technical debt. Let me get my little device. But this was not always, this was not how the original definition of technical debt was coined somewhere in the early 90s by Ward Cunningham. This was not how it was intended. It was intended as a conscious, well-informed decision by a development team, DevOps team nowadays, who sit together and decide, we don't really want to do things this way, but we'll temporarily make a shortcut. We'll violate our policies and our architecture, or any other guidelines we might have in place. But we do this because there's some external pressure, there's some objective. The business wants something and it needs to be done now, and it's for a good reason. We'll do it, but we know full well how to solve this in the future. And also we're guaranteed to get the time to actually put things in place. This is how technical debt was originally conceived. Of course, by now, in the 30 years past, technical debt has grown a little bit, both in size, absolute size, but also in terms of its definition. It's now essentially everything in your way. Everything that slows you down. Everything that makes that you cannot really go as fast as you really want to go. Who here has to deal with technical debt? Yes, so you recognize this. So, and there's an endless variety of technical debt also now. You have architecture debt, build debt, code debt, documentation debt, test debt, automation debt. There's an endless variety of debt, and you can also debate with people whether something fits in the definition or not. But I think we can all agree that there is an awful lot of it. The summary is that you cannot go as quickly as you would like to go, and the whole reason that this analogy, this metaphor exists, technical debt, is not for you. You know what the problems are, you know what's slowing you down. But you're typically also not the person who decides on budgets. So the idea of technical debt is not for you, but it's for those who decide where money and time is spent. So technical debt is actually only very useful if you talk to those that are able to give you the time to do something about this. But if you would get your way, you would probably spend a lot of time on that. First of all, if you, a small note on how much technical debt really exists. If you ask CIOs, you can wonder how much they really know about the total amount of technical debt. McKinsey did, and they asked many of them, how much technical debt do you estimate you have in your, what they so nicely call technology estate? And they said, well, somewhere between 20 and 40%. That is an insane amount. That is an insane amount. And we're not just talking about applications, we're talking about everything that you capture in code here. So if you look at large organizations, that's tens and sometimes hundreds of millions of dollars or euros, however you want to measure this. And what's the problem with this? Well, it's essentially the cognitive load for everybody working at your organization. And you might well know that it's not very easy to find you. So organizations also just don't want to have technical debt because it slows people down. People also don't like to work in organizations with a lot of it. The most interesting thing that they said was it's not just a lot. Almost half of them, or slightly over half of them, said that it had perceptibly risen in the past 3 years. So they saw it getting worse. It's something that's increasing. And these are two very distinct problems that I want to talk about. First of all, if you would solve all your technical debt, you would go bankrupt mostly. Doesn't make any sense. It's often an insane amount of money that you need to spend on solving all of it. And business typically don't want to give you anything. For my work, I spend a lot of time going to, I do advice on software quality for the software improvement group. Spend a lot of time with organizations, and I see very different ways of going about DevOps. And what's very common is that backlogs are filled with purely functional requests. If you have a really good product owner, maybe sometimes they put in some time for refactoring. But oftentimes this doesn't work or is done. Who here has a situation where you actually systematically get to address time on your technical debt on refactoring? Oh, nice. 5% of people, give or take. That jives a bit with what I see in reality. Who would like to have more time? Yeah, everybody. Almost everybody. So there are different ways of doing this, and technical debt is a very useful metaphor you can use to explain to them, this is how much faster we would be able to work in the future if you would invest this. And this is a very tough pitch. I often have to help making this pitch, because at the end of a refactoring sprint, or a month, or a quarter, however you want to plan it, you don't have anything for business. The only thing you have is a nicer environment to work in the future. Right? Maybe fewer problems in operations. But you can prove this. Technical debt has a visibility problem. That's the summary there. Sure, now we know the problem, what to do about it. What I propose we do, and what we actually have been doing for quite some time now, is to look at technical debt as a set of improvement possibilities. No rocket science there, right? So technical debt is a large amount, let's say 40%, 20 to 40%. And if you zoom in, there are many small things that you could do, and you could call them units of improvement, however you measure those. They're definitely smaller than Epic. But if you look at all these improvement possibilities, many of them, if you weigh the time that you need to invest, or the effort, however you want to measure this, that doesn't outweigh the actual future productivity increase. In other words, most technical debt has a negative business case. You might want to address it because it looks better, it's prettier, it's nicer for you, but in the grander scheme of things, you might not be much faster after that. So what you need to do is, on a large scale, and not just for one application or one part for your infrastructure, but for your entire landscape, inventorize where potential positive business cases are. This is also the terminology that people who decide on money like, return on investment. In my experience, only a very small percentage of these improvement possibilities are actually worthwhile. Now, another important point here is that you need to take into consideration your entire landscape, all of it. Because the best view that I would have if I'm a developer on one application is what is potentially the most interesting business case in my application. But if you step back, if you take a higher vantage point and you look from a perspective of somebody who's responsible for a set of applications, I don't know, let's call the person domain manager, I have no idea. Somebody who's responsible for more than one application, they might have an overview and say, sure, you have some inkling of where you need to start investing in your application, but if we look at the 10 applications that I have to look at, most money should actually be allocated here. And do note that this budget, as we just established, is often not explicit. There's not a bag of money to solve technical debt. If you follow this logic, the best stance that you can take is the entire landscape, all of it. Because only then you can spend the very limited budget that you either explicitly or implicitly have on the most effective technical debt in your landscape. And the downside is, this might not be your application. And what you see is the opposite is happening in the past 5 years with the advent of skilled agile, more autonomous teams. That means that many organizations say, my team should solve this. They get to decide. And that's very useful, that's very powerful, but it doesn't mean that that these types of analysis shouldn't be done from a centralized point. You see the opposite happening in reality. Cycle is very simple then. What you do is you inventorize all your technical debt over all the technologies that you have. Doesn't matter whether it's Java, Python, some arcane version of Fortran, it doesn't matter. And there are models out there that can actually compare these on the same level. You automatically prioritize these for a nice return on investment, and then the automation stops. Because you still need humans to make the final decision. It's much like tooling that you might use to control the quality of code. It doesn't help if the tooling tells you that you have 10 million violations. It's not useful, you'll just click it away. What you want to know is, what are the 3 violations that I really need to address that are the biggest problem given my business context? Same for this. So you need to make the final decision, but you need to be informed on what are the most likely candidates, or the most attractive candidates to actually pick up. That yellow bubble has the actual work. Somebody needs to do the actual refactoring still. And then you repeat this cycle, given the new state of your landscape. You need to automate this as much as possible and not have discussions on what you think is the most pressing piece of technical debt that you want to pick up. The budgets will never increase this way. We need to make a stronger case together to solve technical debt. So now we talked a little bit about how to solve existing technical debt. But these CIOs made another point, which I personally find far more interesting. Technical debt is everywhere, a thing of the past, we'll need to deal with it, and there are some methods to do it. That's the summary. But we're also making technical debt. So the mistake that I made 20 years ago, that's a mistake that's still happening right now. And that's kind of strange, because we can do something about this. I can't find an English version for this Dutch expression. Dweilen met de kraan open. I asked around. Apparently it also does not exist in French or Turkish. I checked yesterday. The notion is very simple. If you clean the result of a leakage, it makes a lot of sense to also think about the source of the leakage and close the faucet. That's something that is not happening a lot. Who here does explicit code quality control? Who has the tooling on but doesn't really always look at the results of the tooling? Yes. There's some famous standard tooling that is used, but it's often turned off because it's not so helpful when you're busy. Too many violations and you stop looking. There are many requirements that you can have, or many demands on how you set up an application. The most important one is maintainability. Why? If you follow all of these rules, short units, not so complex, clean the code that you find, automate stuff. I don't have to explain to you guys to automate stuff, that's what you do. Write code only once, all these things are, none of them are very hard. Why is maintainability so important? You can still apply all of these rules and build a SQL injection vulnerability, no problem. But if this is in place, if you've done this well, you can solve it really quickly. Because the person after you, this model is for people, not for code. The person after you will quite easily understand what you've done and solve it. It's in a sense, it looks very technical, but it is in fact a model that captures empathy for other people working with your stuff. And all other findings, reliability, performance, resilience, whatever, all of them are a function of how well you've done this. Because every finding you'll have, and you'll find things for sure, can be solved easily if it's easily changeable, predictable when you touch it. This is how you prevent creating technical debt. Who has something in place for this? For the exact same things, these? Yeah, and does it work? The problem often is that this is the first thing that goes out of the window when you have to do fast things. And that's fine, as long as you make it very clear that you spend some time cleaning it up later. I get to look at a lot of code bases, and they often are the result of 5, 10, 20, 30 years of not doing this. It doesn't look great. Side point here, many organizations have this notion, I think it's slightly old-fashioned already, of this bimodal IT, also a McKinsey invention, where they said, okay, the legacy is such a big problem, let's just put a wall around it, and we'll call that the slow speed. But here we have hip stuff. We have new technologies, young people. The applications have snazzy names, and they're in the nice part of the office building. So it must be good. In my experience, when you measure these, they're exactly as poorly built as the legacy applications. Just using new technologies. It's not enough to use the newest stuff. In fact, really capable developers or DevOps engineers don't like these banal things. They like awesome frameworks and new tooling, and they can use it really well. But code duplication, but that is where the problem is. That's the key thing. That stuff will be around much longer than you think. Is there any space for questions, by the way? I would expect people to do this, but I just saw there's some kind of framework. Should I see it here? If there are questions, I should see them there. You can also shout them out. Am I breaking the protocol? Oh, that your day sucks. It depends who you talk to. If I talk to you, I say, yeah, it's not nice. You have this anchor hanging on your leg when you do things. It's not fun. There are places where they really, really spend a lot of time preventing this. Much funner to work there. Because if you want to do something, you do it quickly and nicely. It's like working in a clean kitchen, in a well-organized garage, where everything is where you want it. And I think most of us are the types here that prefer that. So, on management level, the story is, if you want something, and you have a large amount of technical debt, everything will cost 2, 3, 4, sometimes 5 times as much people, time, or money, however you want to measure this. Whatever variable they find most painful, often time. So management or companies as a whole, maybe smaller companies, they want to be fast. And this is what makes you slow. If the competition can do the same change much faster than you, they win in certain domains. Yes? Yes.
Isn't it often easier because productivity increases a future promise, a vague promise,
Yes.
isn't it easier to do it in terms of reliability and that kind of outages and those kind of things?
Yes. That is better, yes. But the problem is that sometimes really bad systems don't go down. Until they do. The problem is that there's not always a very clear connection between building a software system right, or a software solution, or a whole landscape, however you want to refer to it, and how it operates. That's why there's so much software out there that looks great, but it's really hard to do anything about it. Nobody wants to touch it. So it works, it's stable. And that's why it's so hard to talk about it. You say, this is a horrible application. People say, why? It looks great. Yeah, sure, it looks great. But you never have to put another button in it somewhere. It's horrible, it's impossible. And the problem is that sometimes that connection is absent until it goes down. Now I work at SIG, then they call us and say, hey, we thought it was fine, and now? And then you measure it and you say, well, the investment you need to make it better is the same as rebuilding it. Just start rebuilding, please. That's the quickest way of doing it. So that's a challenge, and that makes it really hard to talk about. You understand this, but the decision makers don't. Some of them say they do. It's a hard conversation. Sorry?
But 10 years in there.
Yeah. Well, they should understand. Don't throw good money after bad money. It's not always an easy conversation, but it's one we really need to have because they're two separate worlds. It's really us versus them sometimes. Okay? I said the most important things I wanted to say. I have two key points that I want to leave you with. So 2 questions. So just to challenge you a bit, keep them in your mind. First of all, do you know in either your corner of the landscape that you work in or for your entire landscape, do you know what improvement in your landscape has the best return on investment? You know what sucks and you know what you would love to change? Maybe you don't like certain development environments or you want to do something with APIs, whatever. But do you know which will have the biggest effect if you would put it in a business case, would actually give you convincing, you can convince somebody with a bag of money to do it. And second, what checks do you have in place to avoid introducing unintentional technical debt? So not the intentional one where you together decide this is a shortcut we want to take. No, the things that you inadvertently put in without thinking. And I don't talk about just clicking on tooling, putting it in a pipeline, and never looking at the results. How do you guarantee as a team that you don't build problems for future generations touching your source code? Thank you very much.
Roglitsen. Alrighty.
Oh,
Hey Werner,
I didn't
thanks a lot. Luckily there's a few more questions to go, so it would be fantastic if you could spend some time on those as well.
It's so awesome that they're there. I could have seen them.
We took care of some technical debt and then it appeared.
Bad code means job security. Yes, it does. It does. I don't know if that's the way you want to do things, though. It does. What's very common, so I do a lot of IT due diligence, and that means that company A wants to buy B, and they have a legal due diligence, and they have a commercial and a fiscal and whatever, all the consultancies are there. But the technical due diligence is mostly nothing more than a good conversation with the CTO. That's it. But the funny thing is, often companies want to buy another company for the software because they're like, they now have 10 users, and we'll do 1 million users, and then we'll make a lot of money. Of course, the key question is, can it scale? What do you need to invest to, in fact, actually scale it? And that question is rarely asked. So we do that type of stuff, and what you see a lot is that in the target company, there is one person, the one person who knows everything. The one person who started the company, and now it's grown, and indeed there are 30 others, but they can't answer any question. Because there are these really, really well thought through abstractions in there that only he understands. Right? So the worst enemy of well-written, maintainable software are smart people with really good ideas. You don't want this. You want Joe Average, I am a below average developer, to be operational on your team within 2 weeks and not 2 years because it's so complex. So that is a way to secure your job. I get to pick questions now. No, don't. You voted. Okay, I'll pick the top one then. Tech debt Stockholm syndrome. What is that? Is it what I think it is? That you love it so much because you're used to it? Who asked that question? Yeah, that you just don't know any better. Yeah, somebody needs to tell you, of course, that there's something better. That happens, that's okay. If you don't know, then you don't know. Right? There's not much I can do about it. What's nice is sometimes you get external views or new people in the team who say, hey, there's a different solution for this, let's talk about it. You can't know everything, especially how quickly things go now. So how do you tackle it? And then that person should be the type of person who says, well, let's look at this alternative solution. These are not technical discussions, these are discussions about humans letting go of their preferences. This is all about communication and the softer side of things, I think. How do you quantify? I saw very quickly one I like. How do you know it's time to stop refactoring? At where I work, we measure code quality on a scale and we benchmark it. We have no opinion on good or bad, we just compare it to the market. And it's a 5-star scale. 3 stars, market average. Doesn't mean great, means market average. 4 stars, optimum. 5 stars, waste of time. If you go for full score, then you're essentially just optimizing as a hobby. It's no longer a business case. You spend so much money on actually optimizing to make it really great and pretty that you actually don't have any benefits in terms of the money. So I would say in the parlance that we use, about 4 stars. Be pragmatic about it. How do you build the skills in your team to prevent the creation of tech debt? Yeah, the funny thing is that it's really simple. I gave you these 10 things here. None are rocket science. People say, oh, high quality code needs to have really senior developers. That's not true. These are really simple things. In fact, it's smaller. You have to write less code. It's a bit like writing normal text. The more you write, the less you actually thought about it. It's really hard to write short pieces of text. So you get, it's not hard to do it, but it requires a certain mindset and in fact just discipline. That's it. One more then? Feel these all day. How can you measure the amount of existing technical debt within an organization? So what you need is a model. I prefer maintainability because it's such a gateway characteristic. All the others are a function of maintainability. What I said, security vulnerabilities are easier to fix if the code in which they are is maintainable. So that's the key thing, the foundational thing. You can measure that at scale. There are models out there that allow you to measure different technologies. So it's technology agnostic, inter-technology comparison, and you can measure how often you violate against certain tenets of that model. And then again, that's benchmarked with productivity benchmark, so you can see if you would solve it, what the benefit would be of that. And that allows you to start reasoning on these business cases that I talked about. Is a monolith bad for technical debt? That's a religious discussion. I shall not take a stance on microservices here. Although I don't think all the microservices, because you just move your problem to coordination between teams. It's really hard. And the only thing I'll say about that is, if you decide to not go monolith and you break up, don't let your teams decide technology. The teams I've met who decided that they would use Haskell for their technology, yeah, nice, that's your hobby, but it's not something that people easily understand. So, no other opinions on the monolith. All right, any other questions? Come find me. I'll be happy to talk to you. Thanks a lot.
Thanks very much, Werner. This is for you. Thank you very much. The takeaway that I'm going to take away as well is that people love their own technical debt and they really care about it, and this is stopping the world from working, but there's more of it in the company, and now stare and compare and find out what you're going to fix first. That's clicking hard for me, so thanks for that.